Flow-based routing. So flow-based routing is a routing technique where routes are determined based on the flow of traffic, that is flow of data. It's not based on just the topology like previous algorithm we have discussed. It's based on topology as well as traffic in the network, and it does not choose just the shortest path but path which have less traffic also. If the shortest path is having more traffic, then it leave that path and choose the next shortest path which have less traffic. So it's based on the flow of traffic. That is why it's called flow based routing algorithm. So instead of always choosing the shortest path, flow-based routing chooses the best path based on the current network conditions. So it takes into account the current network conditions also. And flow means sequence of packets sent from the source to destination, that is called flow. And routing decision depend upon these things: traffic load, number one, network congestion, and current data flow. So these three things are taken into account. Let's see a network in which different nodes are connected, and these numbers represent the capacity of the channel, which is in kilobits per second. So this channel has capacity of 20 kilobits per second. So different channels are shown and their capacity is written on there. So data travel not just from shortest path but also from the lowest congested, which is having lowest traffic. So flow based routing, in flow based routing we have to take into account the time delay, that is time which it takes a packet to travel from A to B, whether it takes less time from this route or it takes less time from this route. It will depend upon the current network conditions. If there is a route from A to B but it's very congested, means there is lot of traffic, it takes more time than to travel from A, E, D, C, then it will take this longer route if it's having less traffic. So the formula for calculation of time delay is by using queuing theory, and it is 1 over mu c minus lambda. So this is the time delay calculation formula. Here 1 over mu means the packet size in bits. So it is packet size in bit. We take 1 over mu as 800 bits. Means we assume that packet is of 800 bits. Then lambda is the mean flow, that is packets per second which flow from A to B. This is the capacity, and lambda shows the how many packets flow from A to B, that is lambda. Then C is the capacity of line, which is in bits per second. This 20 kilobit per second is the capacity of line. Then T is the time delay. So to calculate this, we have to use this matrix, which is showing the traffic from different routes. So A to A traffic is 0. Similarly, B to B, this entry is traffic from B to B, and it is also 0. This is C to C 0, D to D 0, E to E 0, and F to F 0. So these are the 0 because there is no traffic from A to A. So traffic from node B to A is given by this is B and this is A, and B to A is written here. Okay, and this represents lambda. It is actually lambda, number of packets which travel from B to A, which travel from C to A, which travel from D to A, which travel from E to A, and which travel from F to A. And same capacity, same traffic will be here. B 94174, same is 94174. Similarly, this traffic 8324. So this will be same for all the nodes. 332 means it shows the traffic from D to A, and it shows the traffic from C to D. This entry is from D to C or C to D. It's the same. So this is the traffic matrix which is required for the value of lambda, and then we can calculate the time period. As we know that time period T is equal to 1 over mu c minus lambda, and mu c we can calculate from, because we know that c is the capacity of line which we have taken 20, and mu is the value of 1 over mu is the packet size. So the value of 1 over mu is 1 over 800, then we have mu c is equal to 20 over 800, which comes out to be 0.025 kilobits per second, and which is equal to 0.025 into 1000 in bits per second, which comes out to be 25 bits per second. So this is the value of mu c, and for calculating the value of t, we use 1 over mu c minus lambda, and its value is 1 over 25 minus 9, which comes out to be 0.0625 second. And if we want in millisecond, then it will be 0.0625 into 1000 millisecond. So it will become 62.5 millisecond, or approximately, you can say approximately 63 millisecond. So this is the time delay which we have calculated. Similarly, we can calculate time delay for all the routes, and time delay is shown for the first one is the 63, which we have calculated, which was 62.5 and approximately 63. Similarly, we can calculate time delay for other routes. Now the time delay from A to B is 63, then B to C is 59, so C to D is 105, and highest delay is between F and D. So we have to consider these time delays along with the topology, along with the shortest route. If shortest route is taking more time, delay is more, then we can take the second shortest route or third shortest route where the traffic is less. So this is the basically flow based routing method, which take into account the topology as well as the current traffic in the network.